Okay, we're finishing up on the calculator portion of this practice AP test. Which of the following is an equation of the line tangent to the graph of x to the fourth plus 2x squared at the point where f prime is equal to 1? So this tells us exactly what we need to do. We're going to find f prime. We're going to set it equal to 1. So to find f prime, we go through power rule. X to the fourth becomes 4x cubed. 2x squared becomes 4x. We take our f prime. We set equal to 1. And this is not something that is factorable, so let's bring everything over to one side, set equal to 0, and we can use our calculator for this. We're going to graph this equation, and we're simply going to look for the x-intercept. Wherever the x-intercept is, that's going to be our approximated solution because that's where it's equal to 0. So once you sketch the graph, you do second trace 0 and then use the calculator to help you find that approximated value, which will give you x is equal to 0.2367. Now, if we want to find the tangent line equation, we also need the y value of this order pair. So we'll take this 0.2367, put it back into the original function. Make sure you don't put it into the f prime. Back into the original function. So 0.2367 to the fourth plus 2 times 0.2367 squared, and that will get us 0.1152. That's our order pair. Our slope is 1. So we have our order pair, we have our slope, and then we just put into point slope form. Once it's in point slope form, we can continue solving for y by adding 0.1152 to both sides, and our equation is going to be y is equal to x minus 0.122. All right, 88. F of x, uppercase F, is the antiderivative of this function. So this is really sitting at an f prime level. All right, this is really sitting at f prime level. Now we're given f of 1 equals 0. We're trying to find f of 9. So this reminds us of this rearranging of first theorem of calculus that we can do. Final position is equal to the initial position plus displacement. So if I put it in a different form or different variable, I can say f of b is equal to f of a plus the definite integral from a to b of f prime. So my a is 1, my b is 9, so I'm trying to find f of 9. I'm given f of 1, so the definite integral from 1 to 9 of natural log of x quantity cubed over x, we can use our calculator for. So that gives us 5.827. F of 1 is 0, so that plus 0 is just going to be 5.827. Number 89, we have a function g that is differentiable, so smooth curve. G of x is less than 0, so g of x is a negative value for all real numbers x, and we have a f prime, okay, is x squared minus 4x gx. Which of the following is true? So all these answer choices are referencing relative max, relative min. All that revolves around f prime and the first derivative test. So let's apply the first derivative test. Okay, so with the first derivative test, we're going to use f prime, set f prime equal to 0. So once we set f prime equal to 0, we can factor the x squared minus 4 as x plus 2 and x minus 2, or you can just set x squared minus 4 equal to 0, you get 2 and negative 2. G of x is just a number, so we're not going to get any critical points from there. So we place 2 and negative 2 onto our sign line. We choose values in each interval. So if I plug negative 3 into my derivative, I'm going to get negative 3 squared minus 4. That's going to be a positive times a negative, which is negative. We're told that g of x is always negative. If I plug 0 in, I get 0 minus 4. That's negative times a negative, which is a positive. And if I plug 3 in, I get 3 squared minus 4. That's positive times negative. That's negative again. So we have a graph that's decreasing until it hits a relative min at negative 2, increases to a relative max at x equals 2, and then decreases again. So we can say relative min at negative 2, relative max at x equals 2. That's answer choice B. Okay, for 89, this is going to be a related rates problem. Base B of a triangle is increasing at a rate of 3 inches per minute. The height is decreasing at a rate of 3 inches per minute. Which of the following must be true about the area of the triangle? Okay, let's set this up using related rates, or having an equation to start off with. We know area of a triangle is going to be 1/2 base times height. And if I want to find, I'm trying to involve something about a increasing, decreasing, so something involving dA dt. So I'm going to find the derivative with respect to time. A becomes dA dt. 1/2 b and h, I can think of these as two separate expressions. I have to go through product rule. F prime g plus fg prime. So 1/2 b's derivative will be 1/2 dB dt. Remember that this is related rates, so every variable, the a, the b, and the h, eventually will all produce its own d over dt's. Okay, so f prime, we said 1/2 dB times dt, or 1/2 dB over dt. G function is the original h times h plus the original f, 1/2 b, and then h's derivative is 1 dh dt. So there's our derivative. We have specific values that we can plug in, 3 in for dB dt, -3 in for dh dt, and that leaves us with dA dt equals 3/2 h minus 3/2 b. We don't know what h and b are, but what we can conclude is that if you look at the fact that these are basically opposites of each other, we can say that if b is greater than h, right, let's say this is 4 and this is 3, as long as b is greater, we know this value is always going to produce a larger negative number than this, which makes dA dt less than 0. So dA dt less than 0 would indicate that the area of a triangle is decreasing. So for instance, if b is 4 and h is 3, just to highlight this general statement that we're making, if I plug 4 in, I get 4 for b and 3 in for h. I get 9/2 minus 12/2, which is going to be -3/2. That's negative. So as long as my b is greater than h, my dA dt is always negative, and so my area of the triangle is always decreasing. Answer choice D. Okay, 91. Function is differentiable. It's a smooth curve from 1 to 10. We have a bunch of order pairs, so I'm going to go ahead and plot them onto my graph. I have f of 2 equals -5. I have f of 5 is equal to 5. I have f of 9 is equal to -5. Differentiable, so I'm going to make a smooth curve out of it. And let's explore these answer choices here. Our function has at least 2 zeros. Can we guarantee that this graph is going to cross the x-axis twice? It's going to start below the x-axis, it's going to go above it, and it's going to come back down. So yes, we can guarantee that it's going to hit the graph at least, the x-axis at least twice. So 2 zeros. The graph F has at least one horizontal tangent, so it has to come up and has to come back down. So it may not be at the 5, 5, but it has to be, there must be at least a point where there's a relative max, right? That's a guarantee. For some c value between 2 and 5, f of c is equal to 3. Can we guarantee that the graph is going to cross through a y value of 3? And again, that is true with intermediate value theorem. We start off below 3, we're going to end up above 3 because the graph is connected. So in this case, it's actually going to hit the graph at least, hit the y equals 3 at least twice, but it's only asking for one value, and we can guarantee that there must be one value of 1, 3 that the graph is going to cross. One instance where the graph is going to cross through a y value of 3. Okay, so all 3 is going to check out. Answer choice E. Okay, for 92, this is an area problem. Between 0 and pi over 2, the area under the curve is going to be 0.1 from some vertical line k to pi over 2. So here's my graph. My graph is cosine of x. So I'm just going to indicate k to pi over 2. This region is going to produce an area of 0.1. So I'm going to go ahead and set that up. The integral from k to pi over 2 of cosine of x dx equals 0.1. Right, we're going to find the antiderivative. Cosine becomes positive sine. Once we find the antiderivative, we can plug in our upper and lower bound. Upper bound gets plugged in first, sine of pi over 2. Then we do a minus, then we plug in the lower bound, minus sine of k. And we know that this result is going to be 0.1. So we say 1 minus, okay, sine of pi over 2 is 1. 1 minus sine of k is equal to 0.1. solve for sine of k. Sine of k is equal to 0.9. I can take the inverse of both sides. So k is equal to inverse sine of 0.9. Plug in the calculator, we get k must be equal to 1.120.